Hi there. So this is Graham, and I thought I'd just do a little video showing how to use the taper turning attachment on my Harrison lathe here, and in particular how to watch for the backlash really, because it can cause problems. And the issue is that with a taper turning attachment, you've got play in the actual taper turning attachment itself over the back here. You've got obviously backlash in the feed screws, your cross slide. So how do you deal with that? Now the part I'm trying to make is actually one of these. It's tapered. It has a hole all the way through it, and this one is just made out of mild steel, but I wanted to make one out of stainless steel, and I thought I'd give it a go. So the first thing I had to do was to drill a hole all the way through, and it's supposed to be 1/8 of an inch diameter. If you've seen any of the videos on the internet, in particular one from Joe Pizzaki, who describes how to drill long deep holes, you'll realise it is not a simple matter to get the two holes lined up. Now I've only got standard length jobber drills, and I could just about make it through by drilling from both ends through the part, but of course they didn't actually quite line up. The stock I was using, again I should have listened to Joe, because the stock was very slightly bent, about 4 thou. So when I mounted it in the collet chuck, I got 4 thou run out here, and I couldn't do anything about it at all. I tried moving the part around, everything. I always got 4 thou. I reversed it, and on the other end it was less than 1 thou. So straight away I've got a problem. I'm trying to drill a hole all the way through, or sorry, in two halves. One side I've got a 4 thou out, and the other side I've got nothing. Anyway, it didn't seem to me to be a particularly satisfactory approach of trying to get a perfect hole all the way through this, when in fact all it is, it's the brake column, and it has a spindle that goes through it. So and it just operates the brake. So what I've done is, on the end that's inside there, I've just put a bush, and I've drilled halfway through a bigger diameter, and then I have a bush in here which is about 10mm long, and I shall just lock tight that in the end, and then that'll be fine. But now the taper turning. So what do you do? Well, I am going to cut the taper towards the headstock, and I want to make sure there's no backlash. Now the way to do it is to come well past your starting point. This is where I'm going to make the cut, but bring the taper, bring the saddle well past the start point. Now bring it through until you're about at the right point. You can now feed in, put in your cut, and complete the turning. So here we go. Not quite right. So I'm going to put on a cut of about 0.5 millimeter. Engage the power feed, and what this will do, because we took the backlash out by moving the saddle this way up towards the tailstock, it will mean that I've got a nice parallel part. I should say something about the setup and how you actually get the taper. It's relatively straightforward if you've got a digital readout. But let's just stop this when we get towards the end. That's it. So I can now back off, come well past the end of the part. That starts, now bring it back, and I'm taking out the backlash out the taper turning attachment. Come back to where I want. And I'm ready to take the next cut. But let me just say something about the setting the angle. I've done a drawing. I'm not sure whether you can see that particularly well, but basically I know the length. Put it up the correct way around. The length here is 2.799, and the radius, sorry, the diameter at that point should be 0.375, 3/8, and the radius at this point should be 11/16. Is that right? Yeah, 11/16. So, sorry, I'm lying. It should be 3/8. So we've got 3/8 diameter here, and a diameter at this point of 0.223. So I'll just say that again. 0.223 at this end, 0.375 at this end. So by just setting the top slide as an arbitrary position, and then zeroing out, sorry, not zeroing out, set your X reading to 0.223, move it along 2.799, and the reading should be then 0.375. So it's an easy way with a digital readout of getting the angle actually very, very accurate. In my case, I mean, I think it's actually a couple of thou out, but that's not important. Right, so I'll just do one more cut and show the principle again. The steel is 303 stainless. I'm using a circular insert for profiling, and the speed is 800 RPM, and the feed rate is, if I just say AS, is 4 thou per revolution. It's leaving quite a nice finish. And this 303 stainless steel seems to be cutting really nicely. Just approaching the end of the cut now. There we go. So back it off. Go well past the end. Take out the backlash. Next one, bring the cut in. Now I made a mistake then, I backed off. So come in, nope. It's important to get this backlash out properly, so come all the way back. And then just to where we're going to start the cut. About there. Right. There's quite a few more cuts to go, so I'll stop it at this point and then come back later on once we're ready.